Good evening, YouTube. Needlebender785, Ohio. We're bringing you here another video with a completed, and I was going to say completed with a little asterisk, 98.9% probably, because there's a few wires that need to be connected, but it's operational, and we're actually going to have it running here. Not running, but we're going to have the bottom deck, the low voltage, and by low voltage I mean 110, 120 volts, and the 12 volt circuits all tested. But right now we'll talk about what we got going on here. And of course, people are texting me like crazy as I'm trying to make a video. Okay, so when I shot this video last time, these relays were not here. The keying circuitry was not there. This bank of resistors was not here, and none of this was interconnected. So now we have everything connected except, damn it, the B negative needs to be connected, and there needs to be one more resistor. It's the 20K 100 watt resistor. That's a tube cutoff resistor. I don't have it. I will have it on order. Should be here in a couple of days, and it's probably going to go here somewhere. And the wire from the high voltage negative power supply from the metering circuit is going to come in here and go to this relay right here, and that's our bias keying relay, and this is our main keying relay. We are going to key this thing up, not with any kind of RF, but just because this thing, amplifiers this size do not have a RF sensing circuit, so you can't just, you actually have to use a foot pedal or one of these new smart radios that actually sends an RCA signal to key this amplifier up. So what we have going on here, let's talk about this relay sequence. So we have two timer relays. These are 110 volts, that's 120, they run on 120 volts, and they have a delay from anywhere from 5 to 60 seconds. You can set the delay. So we have two timing circuits. We have one to warm up the filaments on the tube, that's this one, and one to step turn on your high voltage. So it lets your high voltage slowly get up there before it turns on the full juice. And that's called a soft start. So we have a soft start for the filament and a soft start for the high voltage. So the filament is easy. You need 150 ohms of resistance. So we have a 100 ohm and a 50 ohm in series. And so basically what happens is, when you first turn on the master power supply, you have these two bus bars. That's a neutral bus bar, and that's a hot bus bar. So when a power comes out of the small small fuse, it goes to a switch, to the master power switch, which is right here. We're not using the switch right now to test this, so I have it bypassed. I have the power powering directly to the bus bars, because we don't have 240 or 220, whatever you want to call it. We're just doing it with 110 volts. So, so power comes in here, then goes through this fuse, goes into the power switch, and then energizes the hot bus bar, which is the bottom one. The neutral one, that's neutral, that's the top one. All the neutral stuff is connected there. After that, when those bus bars are energized, this 12 volt switcher, which is our auxiliary power supply, runs all the 12 volt equipment on this amplifier. Comes in, you can see the LEDs on because this thing is under power right now. I was just running and doing some tests prior to this video, and so it is on right now. So anytime this bus bar is energized, this is running. So whenever this is running, this blower will also be running. Now I notice this blower will not be running. This is a high voltage transformer blower. It's only going to run when the high voltage transformer is on. Now this is a tube blower. Now this one's going to run anytime the master switch. So right now it should be running, but it's not. One simple reason: I didn't have it wired today. Just didn't have time to finish that. But pretty sure I can figure that one out. But anyway, back to the video. so next is you have 12 volts right here on these. Negative of the 12 volt is grounded to the case. So case ground is also our minus, which is kind of like a car. Anything else we can tap anywhere and get minus 12 volts. Then we have this switch right here. Takes the 12 volts from the positive, goes through the switch, and goes to this first relay right here. And immediately fires up this relay, and it allows 110 volts on the other side of the set of contacts to go through there, through this bank of resistors, and into the filament transformer. And it slowly heats up the filament. It also starts this timer. When this timer expires, it fires up the second relay and actually turns on the filament full bore, basically full speed, full power to the filament. At that same time, it also engages this first Allen Bradley, which is, it allows the high voltage to slowly start rising, and it's utilizing the 100 ohm resistor, which is all by itself right here. And it's charging that capacitor bank. And it's doing that until this timer expires. When this timer expires, it sends a signal, closes the second Allen Bradley, bypassing this 100 ohm resistor, and sending full power to going up there. As you can see, there's a rubber grommet up there to the high voltage transformer, which is not there. It's actually still on the floor over there. Let's take a look at it. So don't have to worry about any kind of high voltage, as the high voltage transformer is sitting in the corner. So we can, this is a good time to play around with this box and test stuff, because we don't have any high voltage to deal with until, for two reasons. You can really tune this thing and make it work and then flip it over, because it's, once you have that installed, it just becomes really heavy to have to work on this side of the amp. Anyway, so also when this turns on, when this first Allen Bradley turns on, it turns on this fan right here. However, this is a 240 volt fan. That's just what I had on hand. That's why it's not going to turn on during this demonstration, because we have a just an isolated 110 volt supply, which I use when I'm testing something that's brand new. That way it's isolated from the ground, but it's also variable. It's a isolated variac. So what we're going to do, we're going to hook up this meter right here. We're going to do this live on video, so you guys can see what's going on. There you go. I do have this grounded just for case ground. I don't know why, but just felt like grounding it. And there is no leak or anything like that. But anyway, we are going to step start this using this switch. And you can pay attention to the relays and the lights on the relays and the lights on the timers, and also the sequencing of these. There we go. So the first relay turned on, and the first timer's turned on. So now the filament's on. You have voltage on the filament, which should be 12.6, but this is not under load. So now you have everything on, and now we're going to shut this off. There you go. So we're going to try it one more time. One on. There you go. So it's working as it should. And we're done for today. It kind of took all day to wire this up. And we're going to shut down this little guy right here and unplug it. Even though this is not high voltage, it's still very unpleasant to put your hands in it. Okay, so like I said, so the only other thing that's left is the B negative going into this bias relay. The actual bias board that I've talked about in my previous video. It's going to go right like this, or like this. I don't know, I gotta mount this right here and wire this fan and flip it over. And I'm not going to do any more videos on the bottom side because there's literally nothing else that's going to be other than this thing right here, and we talked about it. This is the bias control board. And that's it. The next video is going to be on the output tuning circuit. Anybody has any questions on how something like this is wired or where stuff goes? Like I said, drop me a line. None of this is a secret. I'll, if I can share a schematic, or I can tell you what's connected to what, but it's very simple. 2 timer relays, 2 regular 12-volt relays. This is a bias relay. This is your keying relay. And the center tap of this filament transformer is connected. As you can see, it's connected to the bias relay. So all this relay does, let me talk about this real quick. So all this relay does is bypasses the 20K 100-watt resistor. So the tube should never ever be disconnected from B negative. Otherwise the tube goes floating, out of control. You don't want to have that. So the tube always, even the time that the relay clicks over, the tube should never be out of control. So the tube should always be connected physically to B negative, whether it's through a resistor or through a relay. So what you have is B negative going into the bias control circuit, which is, we just had that right here, bias control circuit. After it exits the bias control circuit, it goes to another one of these resistors and then goes to the center tap. Now this resistor here gets bypassed by the keying relay, by the bias relay. All it does is shorts out this. So the tube always has a connection to B negative, whether it's through a resistor or through the relay, but it never goes floating. That's the main thing. You don't want to have the tube without having that B negative applied to it at the cathode level. When there is a 20 key resistor, what happens is it floats up about 40, 50, 60 volts, and the current gets so low that it goes in a cutoff. Now some other tubes, like 3500Zs, you can do that, or if you're operating on the other frequencies, you can also inject a positive voltage into your cathode, which will bring it above the grid, and that's why your SB220 uses the 90 volt AC circuit, which when rectified gives you 110 volts, and it brings that tube in a cutoff instead of this. So this is like a self regulating circuit, which works. It works in your 3CX3000, works in this, but if you're like running a 3500Z, you could use that too. But if you want to kind of basically guaranteed to shove, so this is kind of like a passive circuit, which works great, or you can utilize an active circuit and actually force the tube in a cutoff by applying a positive voltage to the cathode. So if the grid is below the cathode, which it becomes, then the tube goes in the cutoff. Anyway, that's what we got going on. 73s, and we'll see you in the next one. Needle Bender 785 Ohio, back on the side.